Hi everyone. Today's lesson is all about angles and angle relationships. Let's start first with the definition of an angle. So an angle is a space between two lines or rays that meet at a common point called the vertex. It is measured in degrees. So here in my illustration, we can see that there are two rays and they meet at this point. We call that the vertex. The space between the two rays, that's what we call the angle. Now, there are different types of angles. So the first one is what we call an acute angle. An acute angle is an angle that measures less than 90 degrees. For example, 80 degrees. All right, I'm not sure if this is 80 degrees. So I'm just assuming and approximating. Okay. If it's exactly 90 degrees, we call that a right angle. That should be degrees like that. All right. Okay. So if it's more than 90 degrees but greater than 180 degrees, we call that obtuse angle. So let's just say here, I will again estimate the measurement of that. So let's just say it's 120. If it's exactly 180 degrees, we call that a straight angle. Now, if it's greater than 180 degrees but less than 360, we call that reflex. Now, one full rotation is exactly 360 degrees. All right, so let's move on to what we call angle pairs. What do you mean by that? Now, angle pairs are two angles that have special relationship between each or with each other based on their position or the sum of their measures. They often appear when lines intersect or when angles are placed near each other. All right, so I have four examples here of angle pairs. This is the first one, and this is what we call adjacent angles. This involve two angles. So what are the angles that are involved here? Angle EFG and angle GFH. Okay, so these two are adjacent angles. Why? Because of these two things. The first one is they have a common side. So the common side is GF. And then the next common thing between the two angles is the vertex. So vertex F. So if two angles have a common side and a common vertex, we call those two angles adjacent. The sum of the measurement of those two angles is actually irrelevant. It doesn't really matter what's the sum is. So in this case, I think it's 135. Sometimes it's going to be 90, sometimes it's 40. Again, it doesn't matter. The sum is irrelevant. You just need to focus on these two things. So the first one is that there is a common side and a common vertex. So if you see those two things, we call them adjacent angles. Next is what we call vertical angles. So here, the vertical angles are M and J, and then angle L and K. So let's relate that to the adjacent angles. So in adjacent angles, we have two common parts, right? So here, the only common part of the two angles is the vertex. That's it. There's no common side. Okay, so what's unique about vertical angles is, as you can see, they are equal. Right? So 70 degrees for angle M and J, and another 70 degrees for angle L and K. So vertical angles actually happens if there are two lines intersect. Okay. Now another vertical angles here that are given are M and L and J and L. Again, the common part between those two angles is the vertex N. That's it. There's no common side. And then the measurement are the same. 110 degrees for M and L and 110 degrees for J and K. Okay. Now, common type of angle pairs. The third one is what we call complementary angles. And then, of course, the fourth is what we call supplementary angles. Now, what's the difference between the two? So, complementary angles, these are angles with a sum of 90 degrees. Now, here, we have angle ABC, which is 30 degrees, angle CBD, which is 60 degrees. You add the two, that equals 90 degrees. Now, in this illustration, you can see that the angles are also adjacent, but it's not always the case. So, complementary angles can be adjacent or the angles can be separated. So, for example, I have an angle here let's say this is uh, that's an ugly angle, and so this one is also ugly, but never mind. So let's say this is 80 degrees, and then there's another angle which is 10 degrees. Now these two angles are not adjacent, right? But if you add 80 plus 10, that's equal to 90 degrees. So we can classify 80 and 10, or the two angles that I draw, they are complementary as well. Okay, again, complementary angle doesn't necessarily need to be adjacent. Same with supplementary angles. So for supplementary angles, if we add the two angles, the answer will be 180 degrees this time. So in my illustration here, the angles are adjacent, but again, in reality, there's a possibility that the two angles are not adjacent. Same with complementary angles. Okay, so what do you mean by linear pair? Another term that we need to remember in our lesson for today. So linear pair is a pair of adjacent angles, of course, next to each other that form a straight line. This means that the two angles share a common side and a common vertex, which is a definition of adjacent angles. The non-shared sides of the angles form a straight line, which of course, if you measure that, that's going to be 180 degrees. So that means also that the sum of the angles is also equal to 180 degrees, which means they are supplementary. So this is a perfect example of a linear pair. Okay, so linear pair, adjacent and then supplementary. Take note of that. But if we're only talking about supplementary angles, it doesn't necessarily mean that they are adjacent. Okay? All right. So what are, or are vertical angles adjacent? I think I mentioned that earlier and I emphasized that. No, vertical angles are not adjacent because there is no common, that is right, there's no common side, there's only common vertex. So these are the key differences of adjacent angles and vertical angles. So share side, no. Adjacent angles, yes. Share vertex, yes for vertical, and then yes as well for the adjacent angles. And then next to each other, no. They are opposite, yes for the adjacent angles. So do complementary angles need to be adjacent? I think I already mentioned that. The answer is obviously no. Complementary angles do not need to be adjacent, but of course, there are a possibility that they can be adjacent, similar to the illustration I gave you earlier. So they can be adjacent next to each other and sharing a side, or separate, not touching at all. What do you mean by congruent angles? So congruent angles are angles that have the same measure in degrees, even if they face different directions or are different in size visually. So an angle measuring 45 degrees is congruent to another angle that also measures 45 degrees. Two right angles both 90 degrees are congruent no matter their size in a drawing.